All right, so we looked first at this function. Now we know that with a degree of 3 and a leading coefficient that's minus, we know it's going to do an opposite kind of thing in the end behavior. So we know as x heads towards minus infinity, the function is heading towards plus infinity. And we also know if we put in larger and larger positive values of x towards x going to positive infinity, then the function goes to negative infinity. So those are our end behaviors. As x goes to infinity, f of x goes to negative infinity, and as x goes to negative infinity, f of x goes to positive infinity. Domain and range. Well, domain for all polynomials is straightforward. It's always all real numbers. And Cami doesn't have that nice symbol, so you can always write all real numbers. Odd polynomials are similar. They're all real numbers because they go from minus infinity to plus infinity, or from plus infinity to minus infinity, depending on how you might talk about it. Even functions, even polynomials are different. They will have a bound, and then will either go to plus infinity or minus infinity, but this is odd. All right, so relative maximum and relative minimum. So we've got two turning points, one here and one here. So the first one is lower than all the nearby points, so that's a minimum, relative minimum. So that happens at 1.184 and minus 1.089. The other turning point is higher than the nearby points, so it's a max. And that happens at x equals 2.816, and the output there, the value of the function, is 1.089. And the x values of those turning points actually define the intervals too. We always start at whatever the function is like from at minus infinity. And so if we look at x tending towards minus infinity, we know the function is going to be positive. So if I start at an x value of minus infinity and I travel along putting in larger and larger values of x from minus infinity to plus infinity, my decreasing interval, it's going to be decreasing until it hits the turning point at x is 1.184. And at that point it turns, and now for x values that are between 1.184 and 2.816, the function's increasing. And then when it hits the turning point at 2.816, now it's decreasing again. And that happens all the way until x is plus infinity. So remember that we talk about x values for defining where the intervals happen. X is kind of your where variable, and y or f of x is your what or function value. All right, well, I hope this all-in-one example helped, and I will see you soon. Thanks.